The problem is from GATE 2016 mathematics paper, question number 26. So the problem given is, let gamma is the circle Z in C such that mod Z equal to 2. That is, gamma is the path on the circle mod Z equal to 2. Be oriented in the counted clockwise direction. Let I is given as 1 divided by 2 pi I times circle integration Z to the power of 7 cos 1 divided by Z square dz. Then the value of I is equal to, so it is given a circle integration, then it is asked the value of this integration. The NPTEL reference to solve this problem is Module 6, Lecture 5 of Complex Analysis. The title of this lecture is Residue Theorem and Applications by Dr. P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. Even you can watch this reference video using this YouTube link. So now coming to the solution, it is nothing but just a straightforward application of residue theorem. So residue theorem tells us that roughly one divided by 2 pi I integration over a path gamma f of z dz is nothing but summation over ai residue of f at ai, where this sum runs over all the singularities inside gamma. That means the singularities inside this circle or inside this curve gamma only matters. Whatever the singularities, if there exist outside this path, gamma does not matter. So now by using this, we solve our problem. So our function or gamma is given as z in C such that mod z equal to 2, and it is asked and it is given I is 1 divided by 2 by I times circle integration over gamma, as the gamma is nothing but the circle, z to the power of 7 cos 1 divided by z square dz. So now we have to calculate the value of this integration. So by straightforward, by using the residue theorem, we can see the residue theorem we have I is nothing but z to the power of 7 cos 1 divided by z square dz is nothing but the sum of the residues of this function z to the power of 7 cos 1 divided by z square at the points ai. So where ai runs over are singularities of the function z to the power of 7 cos 1 divided by z square. So now if we can look at the residues at each singularity of this function z to the power of 7 1 divided by z square, we can look at the final answer. So for that, so since it is given z to the power of 7 cos 1 divided by z square is our function, and by just looking at this function we can easily see z is the only singularity. Since, okay, let me explain. Since z to the power of 7 is entire, comma, cos 1 divided by z square as has a essential singularity at z equal to 0, and at and all z in C minus the singleton set 0, cos 1 divided by z square is analytic. That is nothing but cos 1 divided by z square has only one singularity, that is essential singularity at the point z equal to 0, which can be seen why it is essential singularity. Since when we look at the expansion of cos 1 divided by z square, the Lorentz series expansion, we can see there exist infinitely many terms containing the powers of 1 divided by z. That is, and in fact, we have we have cos 1 divided by z square is nothing but 1 minus 1 divided by z square into 2 factorial plus 1 divided by z to the power of, sorry, 1 minus 1 divided by z square whole square into 1 divided by 2 factorial plus 1 divided by z square whole to the power of 4 into 1 divided by 4 factorial minus 1 divided by z square whole to the power of 6 into 1 divided by 6 factorial plus and so on. This is the expansion of cos 1 divided by z square. Hence, z to the power of 7 into cos 1 divided by z square is nothing but z to the power of 7 minus z cube into 1 divided by 2 factorial plus, here we get 1 divided by z to the power of 8 and into z to the power of 7 is nothing but 1 divided by z times 1 divided by 4 factorial minus, here we get 12. So that means z to the power of 1 divided by z to the power of, here we get z to the power of 12 and 7. We have 1 divided by z to the power of 5 into 1 divided by 6 factorial plus and so on. And of course, we don't need the terms containing the powers more than 1 divided by z square. So since it is, we are calculating, we are looking at for the residue of this function, that is nothing but the coefficient of the term 1 divided by z in the Lorentz series expansion, and this is nothing but the Lorentz series expansion at about the point z equal to 0, since z equal to 0 is the only singularity of this function. So, and this is the Lorentz series expansion. Hence, this is the Lorentz series expansion. Therefore, residue of the function z power of 7 times cos 1 divided by z square at the point, okay, let me write in this way, residue of this function at the point z equal to 0 is nothing but the coefficient of the term 1 divided by z, that is nothing but 1 divided by 4 factorial. So that is nothing but 1 divided by 24. Hence, by residue theorem we have, therefore 1 divided by 2 pi I times integration, circle integration over gamma z to the power of 7 cos 1 divided by z square dz is nothing but 1 divided by 24. Since z equal to 0 is the only singularity and that contains inside this given curve gamma, inside this curve gamma, so this integration is nothing but the residue at that point z equal to 0 only. If suppose there is, if suppose the gamma given curve is a another curve which does not contain 0, then that is nothing but the residue. There are no, since there are no other poles or singularities of this function, in that case we get this integration is as 0. If in the case when gamma does not contain the singularity 0, but since here it is given gamma is equal to mod z equal to 2 and 0 contained in this path, inside this path. So we get this integration is nothing but the residue and the singularity, and that is nothing but 1 divided by 24.